On this question, a store manager combined nuts and M&Ms to make trail mix. She created 10 pounds of mix and sold it for $5.10 per pound. The price per nuts is $3 per pound and the price of M&Ms is $6 per pound. How many pounds of each type did she use? So she's taking and mixing things together. This is definitely a mixture problem. We need to figure out some sort of formula that we're going to use here, and it's actually stated here we have dollars per pound. It's written a couple of different times, and we're talking a number of dollars per pound. This is a very natural equation to use, and what this equation tells me is that we'd be multiplying this by a number of pounds, and we'd be getting a number of dollars. So setting up my chart, I'm going to say let's go price per pound times the number of pounds equals the number of dollars. And we have this both for M&Ms and for peanuts. And since this is a mixture problem, I'm going to go ahead and write a total row on here as well, because I know I'm going to need it. Alright, let's see, filling in numbers. She created a total of 10 pounds of the mix, so this is the number of pounds in total, so that should be down here. This is 10. She sold it for $5.10 per pound, so this is one of those interesting this is one of those instances when it actually does make sense to, this is our rate here, to have a total, a rate for the total. Basically because it was given to us. If the price of nuts was $3 per pound, so we're given the rate for nuts. Does it ever say peanuts, or am I taking that? I guess it was just nuts, wasn't it? Whatever, I'm going to stick with peanuts. The price of nuts is $3 per pound, and the price of M&Ms was $6 per pound. Okay, filling in those numbers. Those look like all the numbers that were supplied to us on this problem. You'll notice in this row I have two of the three quantities already, so I can say, well, if it's $5.10 per pound and it's 10 pounds, multiply those together. This is a total of $51 worth of goods. And I think that's about all I can figure out here, so I need to introduce some variables. And my same reasoning as before, if I'm introducing an x and y, I'd rather have it on this side of the equation than on this side of the equation, because I can multiply these together to get 6x as opposed to having to divide to go back the other way. Over here I get 3y. Okay, so my full chart is filled out. My two equations are right here and right here. Even though this column has a rate down here, adding those two numbers would not give us this number anyway. So even if you have the rate down there, that's never going to tell you one of your equations. Generally, it's these columns over here. It's whatever your non-rate columns. So my two equations are x plus y equals 10, and 6x plus 3y equals 51. So you can see this equation says the total, this is total weight. So the total weight of this mix is 10 pounds. That makes sense. The weight of M&Ms plus the weight of peanuts should be 10 pounds. And this is the total value. 6 times the number of pounds of M&Ms plus 3 times the number of pounds of peanuts. This is the value of the M&Ms. That's the value of the peanuts. Should be worth $51 total. And, again, whenever you set up these systems of equations, or whenever you set up an equation, your units should work out like this. This is a number of pounds, a number of pounds, and a number of pounds. This is a number of dollars, that's a number of dollars, and that's a number of dollars. Alright, to solve this system of equations, I think I'd like to, I'm noticing I have a 3y here and a y here. I'm going to eliminate my y's. I'm going to use the elimination method, and specifically I'm going to make this into a negative 3y. I could have just as easily made that into a negative 6x when I add these together. I'm just choosing the negative 3y because this is, well, it's a smaller number. So I'm going to multiply the first equation by negative 3. This will give me a negative 3 to multiply by this y, and so it'll end up canceling there. But I have to do it to the entire equation. So I get negative 3x plus negative 3y equals negative 30, and 6x plus 3y equals 51. can add these vertically, and the reason I'm doing this is because now these y's will cancel out, the y terms will. I get 3x equals 21. Negative 30 plus 51 is 21. Divide both sides by 3, I get x equals 7. And to find y, well, x plus y equals 10. 7 plus y equals 10 means y equals 3. So that means it must be 3 pounds of M&Ms. Yeah, let's rewrite that. M&Ms. 3 pounds of nuts. My last step before I actually submit the answer, I want to double check to make sure this is correct before I submit it to the on a test or on a homework or anything like that, because I want to make sure that I have the correct answer. First off, I know that 7 plus 3 is 10. That's easy enough. Also, I want to make sure my total values work out here. 7 times 6 plus 3 times 3. It's a total of $51 of product. And according to my chart here, it should have been a total of $51. It's 10 pounds, so it would sell for, so you would want to sell it for $5.10 per pound. So that right there is the answer I'm after.